numerical aperture decides if um,
So try to redefine the whatever. Okay. So there are some content relevant. So click on that. Okay. Okay, Sir. Clear?
yes, sir.
Okay. Then Shivani, what? Unmute yourself.
Sir, sir,
Okay. Tell me about
Satish, Satish, for Soumya, கே இருக்கீங்களா? K Soumya, register number 144.
absent, sir.
That's why I'm asking. Okay, thank you, Satish.
Okay, sir. Thank you, sir.
Thank you, thank you. Right.
Shivani. Hope you got
Sir,
What's Snell's law? Yeah, Snell's law. So what is meant by Snell's law? I think.
Sir,
Have the answer? The purpose of Snell's law. Snell's law எதுக்கு வரும்? அது மட்டும் சொல்லுங்க. Okay. Yes. Anyone have the answer? We will wind up the question session and we'll go for the topics. Anyone have the answer for it? What is the purpose of Snell's law or what is Snell's law? It is. Anyone? So the one who answers will get an extra credit in your fiber optics paper. I will give you 2 marks extra. Whatever the mark you score, I will give you 2 marks extra. Whoever answers what is Snell's law is.
sir, refraction, blending of light, sir.
Blending of light. Refraction. Any answer other than that? Yes, I'm looking for none. So I'm giving you 2 extra credits. Clear? 2 marks extra if you answer the question.
Sir, it is used to describe the relationship between the angle of incidence and refraction, sir.
Okay, very good, Shivasundar. Good, thank you.
Thank you, sir.
So, Snell's law, what it is? Mathematical relation. அதுவும் சொல்லிட்டீங்கன்னா கம்ப்ளீட்டா 2 credits.
Sir, n1 sin 5 sin theta 1 equal to n2 sin theta 2, sir.
Very good, thank you.
IC equal to sin inverse of n2 by n1.
Very good, thank you. Thank you, Shivasundar.
Thank you, sir.
So you will get 2 extra marks in your fiber optics paper. Okay, thank you. Then for today's class, is my presentation before you? Is that visible for everyone? Yes, put it in the chat box so that I could verify myself. So I will put up a slide showing you the syllabus. Okay, for unit number 2. Okay, thank you. So when you look at the syllabus for unit 2, it is completely about the industrial application of optical fibers, right? So when we speak about industrial applications of fiber optics or optical fibers, so we all know where the fiber optic cables have been employed. So in the beginning of the class, we might have an interaction or we might have a discussion about where the fiber optic cabling is being used widely. And we might have come to a conclusion that it is widely used in internet communication and wherever the communication plays a vital role. And now we are going to be more specific towards the industrial applications. What we are going to see is about the application area focused upon the industries. process variables. Okay, not for simply communication network or for internet or in application areas related to internet. Clear? So how this fiber optic cabling or optical fibers can be employed for industrial applications. That is what you are going to understand from word number 2. So when you look at the topic it has been framed for, the first topic is about nothing but the types of fiber optic sensors. Okay, take it down. We are going to discuss about unit number 2, industrial application of optical fibers. Okay. In that, the fiber optic sensors, the first topic, is going to be classified into 2 types. One is going to be intrinsic sensor, the second one is going to be extrinsic sensor. So உங்களுக்கு இந்த சிலபஸ்ல ஃப்ரேம் பண்ணி கொடுத்திருக்கிற கண்டென்ட் வந்து கொஞ்சம் டிஃபைன்டா இருக்காது. இப்போ நான் சொல்லக்கூடிய விஷயத்தை அத மாதிரி எழுதிக்கங்க. That will be useful for you to understand things. Okay. So the first topic is about fiber optic sensors. The types of fiber optic sensors available. So the 2 types are going to be intrinsic sensor and the other one is going to be extrinsic sensor. Clear? So under intrinsic sensor, we are going to discuss about temperature, pressure and other variable pressure measurements. Other variable measurements. Sorry. So under intrinsic sensor, we are going to discuss about temperature, pressure and other modes of process variable measurements. Okay. So coming to extrinsic sensor, we will discuss about phase modulated fiber optic sensor used for displacement measurement. Okay, and other process variables just like your intrinsic sensor it is. Okay, so in extrinsic sensors it has a division that we are going to discuss about phase modulated fiber optic sensor and displacement sensor கொடுத்திருப்பாங்க. இதுல எல்லாமே எதுல வரப்போகுது extrinsic sensorல வரப்போகுது. Clear? So I want to make this clear for you. So fiber optic sensors are classified into 2 types. One is going to be intrinsic and the second one is going to be extrinsic. So under intrinsic, you will discuss about temperature, pressure, and other variables, process variable measurements. And under extrinsic sensors, you will study about phase modulated fiber optic sensor and displacement sensor. Apart from that, other certain variables that we are going to measure by using the principle of extrinsic ability of the fiber optic cable. Clear? Then we will go into the topic of fiber optic instrumentation system. Okay? So as we speak instrumentation, we are going for measurement. So please do understand that instruments are designed for measurement. Clear? So under fiber optic instrumentation system, we'll go for the measurement of attenuation first. So measurement of attenuation by cut back method. So take it down. So fiber optic instrumentation system. Okay. Under fiber optic instrumentation system, the first measurement is going to be about attenuation. Attenuation by cut back method. Here, the second topic is going to be the same measurement of attenuation by using optical domain reflectometers. Make it clear, optical domain reflectometers. Okay, this completes your measurement of attenuation. Okay, then we will study about scattering loss measurement. The second measurement is going to be about the scattering losses. Okay, the third measurement is going to be upon absorption measurement or fiber absorption. Here, measurement of fiber absorption or fiber absorption measurement. Here, then followed by you will study about dispersion measurements. Here, so under dispersion measurements, end reflection method and near field scanning techniques will be included. Here, so we will study about dispersion measurements. After that, you will study end reflection method and near field scanning techniques. So this completes your fiber optic instrumentation system. Then different types of modulators. Make it clear. The next topic what we are going to study is about the modulators. Different types of modulators. So under different types of modulators, you will have electro-optic modulator. Okay, so electro-optic modulator accompanied by interferometric method of measurement of length. Okay, clear? So make this clear. We are going to study about different types of modulators. Under that, the first one is going to be electro-optic modulator. Under that, interferometric method of measurement of length, and then by method of Moir fringes. Here, under method of Moir fringes. So this completes your electro-optic modulator. And the next topic will be measurement of pressure, temperature, current, voltage, liquid level, and strain. Okay? Measurement of pressure, temperature, current, voltage, liquid level, and strain using a optical fiber. So we are going to cover all these topics. For everyone, yes, yes or no? Clear? கேக்குதா சொல்றது நான் சொல்றது கேக்குதுங்களா? Thank you. So ஒரு சிலபஸ் அழகா புரிஞ்சுட்டீங்கன்னு வச்சுக்கோங்களேன், அதுக்கு ஒரு கண்டென்ட்டும் ஈஸியா புரியும். ஓகே, ஸோ நீங்க ஃபர்ஸ்ட் இந்த சிலபஸ் புரிஞ்சுக்கணும். சிலபஸ்ல வந்து டேஷ் டேஷ் டேஷ்னு போட்டு நிறைய விஷயம் கொடுத்துருப்பாங்க. கோர் ஐ வில் அண்டர்ஸ்டாண்ட் திங்ஸ். ஓகே, ஸோ இண்டஸ்ட்ரியல் அப்ளிகேஷன் ஆஃப் ஆப்டிக் extensive types of fiber optic sensors. Clear? Okay. Now we will get back into the topic. So when we speak about sensors, the first thing that might come to your mind will be about two kinds. That is going to be active sensors and passive sensors. Clear? So we all might have studied about the basic classification of sensors upon active and passive. So you know why? What is the meaning behind active and passive sensors? What do you mean by that? What is meant by active? What is meant by passive? You have answers? Anyone? Yes? Anyone can unmute yourself and answer my question. What is meant by an active sensor? Or what is meant by a passive sensor? Yes, tell me. Anyone?
Active sensor needs an external excitation to work.
Active sensor needs an
External excitation to respond to changes.
okay.
And
So an active sensor requires a supply. Whereas a passive sensor doesn't require a supply, right? Is it so? Okay, thank you. Let me get active and your answer. Can anyone just tell me? Because again, if we speak to fiber optics, you tell me about optical source, right? We can make it as simply in general as source, correct?
Yes, sir. Yes.
Yes, sir.
For passive source.
Okay. For passive? Yes, continue. Sharmila, continue.
That is,
So what is audible?
active. Yeah, just now I get it, sir.
Yeah. Yes, go
Simple
on.
as simple active sensors will have its own source of light and also will have a detector for the receiver. And for passive, it only have a receiver. It won't have a source of light where it will give its own light. That's what I mean.
That's what you understand. Okay, very good, very good. Thank you. Yes. And what is the difference between a transducer and a sensor? Anyone? What is the difference between a transducer and sensor? So we will make things fundamental clear. And then if we move into the topic, you can understand things in a better way. Okay. So, and then what is the difference between a transducer and a sensor? Literally, what sensor is. Definition of a sensor. What does it do? Voice breaking. Is my voice breaking for everyone? Is it? Okay, let me try with a different network name. Yes? I'm looking for answers, please. Yeah. Definition of a sensor. Just tell me what you understand from a sensor. So we have, if you take our mobile phone, you can find multiple number of sensors available. Can anyone tell me what are the sensors present in a mobile phone first? Very good. Divya Lakshmi has answered. Sensor responds to a change in environment factor. So environment variable. Temperature. Okay. Tamil Durga. Sorry. இப்போ நம்ம மொபைல் நிறைய சென்சார் இல்லையா? என்னென்ன சென்சார்லாம் நீங்க பார்த்துருக்கீங்க? சொல்லுங்க. மொபைல் போன்ல நிறைய சரி. சும்மா ஒரு ஜெனரலா ஒரு விஷன். புரிஞ்சுக்கிட்டோம்னா கொஞ்சம் ஈஸியா இருக்கும். எஸ். லைட் சென்சார் வெரி குட். ambient light sensor. Very. Then what is the purpose of ambient light sensor in your mobile phone? Or purpose என்ன? ஒரு சப்ஸ்கிரீன் காணும் கவனிக்கிறீங்களா? Touch screen sensor. Yeah, okay. Capacitive touch screen sensor. Okay, very good. Lakshmi answer பண்ணிருக்காங்க brightness. Okay, very good. Direction sensor. Super. Swarnamala. Very good. Then வேற என்ன இருக்கு? Gravity. Proximity. Very good. Accelerometers. Yes, very good, very good. Yes, we have accelerometers, we have gyrometric sensors, we have proximity, fingerprint, etc. Good. So it is a kind of interactive session now. Beautiful. So we will make way into sensors then. So all these sensors has different variables that are going to be measured. All right. Now let me take halopic also. I will come for that. So we have different sensors present in a mobile phone. Each has its very own purpose, right? And each sensor's output is going to be connected to my CPU that is present in my mobile, right? And you all know that based upon the VLSI development in technology, we have now the CPU that is more powerful than your PC, right? We have a more powerful processor in your mobile phone and compared to that of your PC, and that is how the world is going on here. So my question is, you told me about different sensors that are present in my mobile phone, and all these sensors are going to correspond to a different process variable, or and different environmental variable are going to be measured, and that is going to be communicating to my CPU. Right, that is how it will be. That is how it will be framed as. In between that, you might have signal conditioning circuits, etc., and so on. Now, the question is: do we have any transducers in my mobile phone? We have a transducer in my mobile phone. Yes. This will be quite interesting. So then, do we have any transducer in our mobile phone?
Yes, sir.
Sensor a transducer or not? Yes, very good. Okay, thank you. Is a sensor a transducer? Can we accept a sensor to be a transducer?
No, sir.
No.
Sir, not exactly.
Not exactly. Okay, tell me then. Why can't a sensor cannot be a transducer? Sundar. Sundar, unmute yourself.
Yes, sir. Yes, sir.
Okay. It performs a conversion of energy, any form of, or maybe we can like this form of another, right? Yes or no?
Yes, sir.
Okay. What about a sensor then? Don't you have any conversion of energy that is taking place in a sensor? And
Yes, sir, but a transducer always produces an output as an electrical signal, sir. But in sensor, it is not mandatory to produce an output as an electrical signal always. That's what I mean, sir.
Okay, very good, very good. Okay, thank you. So, but what we can say is that all sensors can be transducers. That is what the understanding is. So, if we happen to have any transformation of energy from one form into another by using an electronic segment or a mechanical segment, we call that as what? A transducer. So, a sensor is a transducer, but not transducer is going to be a sensor. Clear? Because, as you said, a transducer converts the form of energy into an electrical output. Clear? So, we have stated about different sensors that are going to be present in my mobile phone. But these mobile phones are not going to do directly a electrical signal. Maybe form of energy can be produced, and that form of energy will be adjusted into an what electrical energy then. And after it is being converted to a successful electrical energy, that will be coupled to my, computer unit. Central processing unit. Clear? That is how it will be. So the understanding should be a sensor can be a transducer, but a transducer cannot be a sensor. Okay. So a transducer includes all sensors within. Okay. So that is your understanding part. Okay. So when we speak about sensor, we can say that sensor is the environmental effect or environmental variations. So if a sensor is put, if the element, if it is able to respond to the environmental variation, we simply say it as what? A sensor. Okay? And if it produces a signal in a form, we say it as a sensor. Now, getting into fiber optics, we have again the classification as intrinsic and extrinsic type of fiber optic sensors. Okay. So when we speak about intrinsic type of fiber optic sensors, the understanding should be, so we should look for the understanding as, in case of intrinsic sensor, it is going to be dealt about the changes in my light intensity, the changes in my light phase modulation, the changes in my polarization of the light signal that is going to happen inside my optical fiber. So the sensing is going to happen inside my, in terms of my the light ray changes, the parameters associated with the light rays changes. Clear? So that makes intrinsic sensor to be. Okay. So I hope you all understand this. So I will repeat again. So when we speak about intrinsic sensors, intrinsic type of fiber optic sensors, the variations are going to happen at my inside of my fiber optic cable, where the light is going to have some changes in it with respect to intensity, with respect to phase modulation, with respect to polarization. Okay. If I happen to have these changes inside my optical fiber, inside of my optical fiber, I call that as what? Simply intrinsic type of fiber optic sensor. So when I go for this extrinsic type of fiber optic sensor, my fiber optic cable and the light that is going to be carried is not going to be a part in that, in my sensing. Clear? So the sense பண்ணக்கூடிய இடத்துல என்னுடைய fiber optic cable the fiber optic light இருக்க போறது கிடையாது. அப்ப என்ன பண்ண போறது அந்த extrinsic type of sensor அப்படின்னு கேட்டீங்கன்னா, it is simply going to transmit my data, simply going to transmit my sensed signal from one point to another. Here, and we call those as what? Extrinsic type of fiber optic sensors. Am I making this clear for you? Is that clear? Yes? No? Do I want to repeat it? Answers? Yes? No? Answer பண்ணீங்கன்னா எனக்கு தெரியும், இல்லைன்னா மறுபடியும் நான் சொல்லுவேன். No problem. Yes? Anyone? Understood? Okay, maybe I could repeat it again once again. So the classification upon intrinsic and extrinsic type of fiber optic sensors. So when I deal about intrinsic type of fiber optic sensors, the understanding should be the changes in my measurement will cause an effect over my changes in my light intensity or phase modulation or the polarization plane of my light signal. Okay, that is understanding what intrinsic type of fiber optic sensors. As we go upon extrinsic type of fiber optic sensor, not by fiber optic cable or light is going to get affected. Only it is going to play a role of transmitting the sensing data from one point to another. That is it. That is your extrinsic type of fiber optic sensors. Is that clear for everyone? Yes? No? Yes? No? Okay, thank you. Then I am going to present you a slide. So that makes you things clear. Okay. Go to slide now. So now we can see is my slide visible? If not, tell me. I could reshare it again. Okay. I will try to present it again. Is it visible for everyone? No. Okay. Look for slide. Is it now visible? Check. Take it once again. Okay. Now look at the type of fiber optic sensors that are available for measuring strain, displacement, temperature and pressure. So these are all an optical fiber based measuring sensor systems. So an example for how fiber optic sensor may look like. So that is the idea for to make you understand how it will be. Okay. We'll study all these in detail, but just see how the fiber optic sensor will look like. My slide appear clear for everyone? Yes? தெரியுதா? Clear தெரியுதா? ஒரு 5 டைப் பார்க்க முடியும். அந்த 5 டைப்ல சும்மா அந்த டயகிராம் மட்டும் சும்மா பாத்துங்க. Okay? Yes, thank you. Now okay. What are the general uses that we make this fiber optic sensors to be applied for? So the first case, the measurement of physical properties as strain, displacement, temperature, pressure, velocity, acceleration in structures of any shape and size. Okay. So that makes fiber optic sensors. Okay. தெரியல. தெரியுதா பாருங்க. மறுபடியும் பிரசன்ட் பண்றேன். தெரியுதா பாருங்க. தெரியலனா சொல்லுங்க. I will retry it again. Understand the concepts clearly. Okay. So the general uses or general purposes why we go for fiber optic sensors not given here. Okay. We find to measure of physical properties such as strain, displacement, temperature, pressure, velocity, and acceleration. Okay. And second, monitoring the physical health of the structures in real time. So a sensor, if it is being employed, it should give me a real-time data on monitoring. Clear? And that is very much appreciable for fiber optic sensors. So when I employ a fiber optic sensor for a real-time monitoring system or a real-time monitoring of data, it gives me a very good output. And third one is damage detection. Okay. Any damage, if it is present, I could acquire it easily with respect to what applying fiber optic sensors. Used in multifunctional structures. If I have a different combination of smart materials, actuator sensors to be present, I could get use of my fiber optic sensors there, because if I use a simple electrical type sensor or electronic based system, it be influenced by the electromagnetic interferences, again radio interferences. Okay. So if I have different combination of systems to be present, there if I want to apply some sensors, I can surely go for what? Fiber optics. Clear? So that is what for the understanding. So the general uses are the measurement of physical properties, the monitoring of physical health of the structures, damage detection, and used in multifunctional structures where the combination of smart materials and different combination of systems is available. Okay. Clear? So this gives you the general uses of fiber optic sensors. Okay. Now, the next thing, what you need to understand is, I will put up another slide. Check it is visible for everyone. Hope it is visible. Okay. Now take it down. The types of fiber optic sensors. Okay. The types of fiber optic sensors. So under the types of fiber optic sensor, first kind is going to be intrinsic sensor. Intrinsic sensor, or we can say it as an active fiber optic sensor. The first point is going to be the guided light in the fiber gets modulated by the variable to be measured. Okay, that is for your understanding. So the first point of an intrinsic sensor should be the guided light in the fiber gets modulated by the variable to be measured and then demodulated. Okay. So second point, sensing and simultaneous measurements are taking place in the active sensor or intrinsic sensor. Okay. The second point is about sensing and simultaneous measurements. Okay. So we can see here, I'm discussing about 2 points. The first point is about the guided light in the fiber gets modulated by the variable to be measured here. And then the second is sensing and simultaneous measurements are possible. Okay, clear? So the fiber gets modulated by the variable to be measured. Yeah, that's supporting parameters are 4 kinds. Clear? So under intrinsic type, we have first kind to be intensity modulated sensors. Okay, take it down. So for understanding, the first kind of intrinsic sensor is going to be intensity modulated sensor. Okay, so under intensity modulated sensor, what the understanding is that I'm going to have absorption or absorption of light to happen with respect to the variable of temperature, pressure, whatever it may be. If I happen to have the intensity fluctuation in my light, I'm going to acquire onto that. We call it as intensity modulated sensors. In intensity modulated sensors, I'm going to have an acquisition of the intensity of the light to be a parameter. Okay. And second is about the phase modulated sensors. It involves the interference between the signal and reference. So what I will do in phase modulated sensors is that I will split my beams into 2. One I will take it as a reference, another will be sent for a measurement. Okay. So after finding out the phase modulation or phase difference between the transmitted beam and the reference beam, if I happen to find any shift in my light energy, I will acquire that for measuring the variable. So that is the understanding of what phase modulated sensors. And the third one is polarization of or polarization modulated sensors. Okay. So a polarization, I know, you know. So it is with respect to a plane. Okay. So when I send a polarized light with respect to a particular plane, if I have any changes in my polarization, what happens? The light gets completely out of the polarization phenomenon. So upon the measurement of the kind of polarization I apply, I could go for what? The measuring the process variable. Clear? So this gives you the polarization type of modulated sensor. Okay. And the last kind is going to be upon wavelength modulated sensors, where it is going to depend upon the spectral variation. I mean, the wavelength variations and the emission of light. Process variable. So this is going to be your wavelength modulated sensor. So what we have seen today is upon the types of fiber optic sensors. After that, the first kind is basic thing, intrinsic or active sensor. So under intrinsic active sensor, we have four kinds of measurement on intensity, upon phase modulation, upon polarization, and then about the wavelength modulator. So these 4 will come under the types of measurement under intrinsic or active sensor kind. Clear? Am I clear for everyone? Okay. So what kind of fibers will be used? So when I go for intensity modulation, I do prefer multi-mode fibers. Okay. So if I want to simply understand how the intensity is fluctuated or it is under attenuation, I will go simply for what? Multi-mode fibers. If I want to go for measuring the phase modulation or measuring the changes in polarization or the wavelength, I will simply go for single mode fiber sensors. Am I clear? I know why we choose a single mode fiber for intensity instead of intensity phase polarization modulation technique. Okay, because in a single mode fiber it is more confined, the beam is more confined toward the central axis. So if I want to measure the phase modulation, it is most preferable. And also if I go for polarization also, I do prefer what? The same reason for single mode fibers. Whereas in a multi-mode fiber, you all know that the wave propagation happens at different way. I mean, different paths will be used for the light to propagate. So that makes intensity modulation to be the only kind of measurement available. Okay, am I making this clear for you? So what you need to understand is, in multi-mode fiber sensors, only intensity modulation can be measured. Whereas in a single mode fiber sensors, I could measure intensity, phase, and polarization modulation technique also. Okay, is that clear? And you can also include wavelength modulation in single mode fiber sensors. So this completes your basic types of fiber optic sensors, under which intrinsic or active sensors. Clear? Now coming to extrinsic sensor, don't take this diagram. Kindly do avoid this diagram. It is not apt for it. So I will give you a different diagram then. In case of extrinsic sensor, the modulation takes place outside the optical fiber. So take this as a first point. The first point is going to be the modulation that is going to take place outside the optical fiber. Then you don't find any kind of modulation to happen inside, just like your intrinsic sensor. So by intrinsic sensor, we saw the intensity modulation, phase modulation, polarization modulation, wavelength modulation. This will happen inside the fiber. Whereas in an extrinsic sensor, that is not the condition at all. So we don't find any modulation to be taking place inside my optical fiber. So it takes place outside the optical fiber simply. So an extrinsic or passive sensors are supported by these points. The first point is going to be about the modulation taking place outside the optical fiber. The second point, it is going to act as a convenient transmission channel for light radiation. As I said before, it is going to be a transmission channel to convey my sensor data that has been acquired from one point to another. Clear? So that is going to be a second point subsided. So the fiber merely acts as an convenient transmission channel for light radiation. Okay, is that clear? Yes. Okay, then this is enough. Don't take other points. It is enough now. So we had a discussion about the basic two kinds of fiber optic sensors today, about intrinsic and extrinsic. So try to be more clear. When we speak about intrinsic sensor, it is about what? The happenings inside my optical fiber. It is well associated with the light parameters, that is intensity, phase modulation, polarization, and wavelength. Whereas when I speak about extrinsic sensor, it is going to be upon the things that is going to happen outside the fiber. So we don't find any changes in my light signal because of the variable that is going to affect my sensing element. Here, so in extrinsic sensor, please do understand that the modulation takes place outside the optical fiber. Okay, and the fiber merely acts as an convenient transmission channel for light radiation. So these are the two slides that we have completed today. Okay, so I think I have made my point clear. Yes, no, if you don't understand things, kindly put it over the chat, or else I could redo this again. புரியுதுங்களா என்ன சொல்றேன்னு? நடுவில் அப்பப்போ நான் கேட்கறதுக்கு உண்டான காரணம் உங்களுக்கு தெரியும். நெட்வொர்க் இஷ்யூஸ் நிறைய இருக்கு. நான் சொல்ற விஷயம் கேட்குதா இல்லையான்னு எனக்கு தெரியாது. So only. Yes, no. Hope everyone listens. கேக்குதுங்களா? No response. Okay. Now, the next thing, what we are going to see next, it's about the advantages of these fiber optic sensors. Okay, I will put up a window before you so that you can easily understand things. See that it is being displayed. For is it visible? Yes, no? Visible for everyone? No. Okay. See that it is visible now. The advantages of fibers we going to see. First kind, or take down the point. The serious advantages of fiber optic sensors. Take it down. Take down the point. Serious advantages of fiber optic sensors. First point will be easy integration into a wide variety of structures. Okay? Easy integration into a wide variety of structures. So you can see the points in my window. Easy integration into a wide variety of structures, including composite materials with little interference. Including composite materials with little interference. Okay. Second point, inability to conduct electric current. Inability to conduct electric current. Third point, immune to electromagnetic interference and radio frequency interference. This is your basic advantage that we have seen in the previous class. So you can write it here also. Okay. The next point is going to be the lightweight nature. Okay. Lightweight nature. The next point, robust, more resistant to harsh environments. Robust, more resistant to harsh environments. The next point will be high sensitivity. High sensitivity. High sensitivity. Next point, multiplexing capability to form sensing networks. So we can have multiplexing capability to form sensing networks. So you can understand one thing from this point. So you can couple different types of or different multiple number of sensors to a single channel. Okay, and I could make them as a sensing network. Okay, that is very much possible in your fiber optic system. Okay, that is quite impossible in your electrical network. Okay, that makes pretty much difficult. Okay, I need to put some signal conditionings. I need to put some pre-multiplexes so to have my connection be stable. Whereas in case of a fiber optic system, that is not a problem at all. You can simply multiplex multiple number of sensors together or multiple number of data together. Okay? And I could create a simple communication channel or a very single channel for communicating all the sensor acquired data from one point to another. So this is your point behind multiplexing capability to form sensing networks. Then remote sensing capability. Remote sensing capability. And you all know what is the reason or what do you mean by remote sensing capability. At last, multifunctional sensing capabilities such as strain, pressure, corrosion, temperature, and acoustic signals. So this is very important for you. That is, when you go for an electrical type sensor system, it can have either a measurement of possible thing as one variable or another maybe around two variables. Okay. Whereas in an optical fiber system, I could measure multiple number of variables in a single fiber. Okay. So I could apply a single sensor for measuring multiple number of parameters. So multifunctional sensing capabilities makes fiber optic sensor a very prominent role. Here, the multifunctional sensing capabilities such as strain, pressure, corrosion, temperature, and acoustic signal is possible. Okay. Yes. Now, a basic fiber optic sensor system, how it will look like. So that is the diagram given for you. So we have a basic fiber optic sensor system. We have a source for optical fiber. Okay. And then we have a measurement or a variable to be measured. That is going to be upon my transducer. Okay. And you can see again an optical fiber to be present, a detector and electronic processing. Okay. So this diagram is for extrinsic type of fiber optic sensors. Here, this diagram is especially for extrinsic type because we have optical fibers to be present, okay, and it is not going to be exerted by any kind of process variable, or any process variable that is going to be measured are not going to make an impact over my optical fiber or the light that is going to be carried forward. It is going to simply make an measurement over my transducer. Okay, so the transducer performs the sensing signal here, and it is going to transmit my data via optical fiber. Clear? So this diagram is for your extrinsic type of fiber optic system. Here, for an intrinsic type of fiber optic system, the fiber optic cable will itself act as a sensor. So please do understand that this diagram is for extrinsic type of fiber optic sensor system. Here, okay. So this completes the basic things that we are going to cover in the second unit, unit number 2. So yesterday, Shivasundar asked me a question about spot size, right? So Sundar, are you there? So you asked me about spot size, isn't it? Is it pit size? Okay. So it is pit size. I couldn't refer to it anywhere, but what I could relate is maybe this pit size can be somewhat connected to spot size. Okay. Yes. When I speak about the spot size, is nothing but your acceptance cone angle that is present inside your optical fiber core. Okay. So we can have acceptance cone before and after. Okay, clear? So இப்போ என்ன ஆகும் அப்படின்னா உங்களுக்கு ஒரு டயக்ராம் காமிக்கிறேன், புரியுதான்னு பாருங்க. What size? Okay. Others you may leave. This completes your class. Okay. See that it is visible for you. தெரியுதான்னு பாருங்க, தெரியலன்னா சொல்லுங்க. I will put it again. Visible? Shivasundar. காமிக்கிறேன், வருதா பாருங்க, தெரியுதா பாருங்க. Visible now? தெரியுதா? Okay. So எடுத்துக்கோம் இல்லையா? அதுல இந்த ரைட் சைடுல பாத்தீங்கன்னா you have a light distribution to happen. தெரியுதா? நான் அப்படி மூவ் பண்றது தெரியுதா? ஸோ இது வந்து ஆப்டிக்கல் ஃபைபர் கேபிள்குள்ள நடக்கும். ஓகே, அந்த கோர் ரீஜன்ல லைட் வந்து ஃபோக்கஸ் பண்ணி அனுப்புறோம் இல்லையா? அது டிஸ்ட்ரிபியூட் ஆகும்போது இந்த மாதிரி டிஸ்ட்ரிபியூட் ஆகும் உள்ள. ஓகே, இந்த மாதிரி டிஸ்ட்ரிபியூட் ஆகிறதுக்கு கொண்ட அந்த இதுக்கு பேர் என்ன சொல்லுவாங்கன்னா ஸ்பாட் சைஸ்ன்னு சொல்லுவாங்க. சரியா? This is what spot size is. Maybe நீங்க அந்த சொன்ன அந்த பிட் சைஸ் இது கூட தான் ரிலேட் ஆகும்னு நான் நினைக்கிறேன். சரியா? இந்த டயகிராம் பாத்தீங்கன்னா இன்னும் கிளியரா புரியும். புரியுதா? ஸ்பாட் சைஸ் இப்படி கன்வர்ஜ் ஆகி டைவர்ஜ் ஆகுது இல்லையா? அந்த பாயிண்ட்டுக்கு பேர் என்ன, அந்த சைஸ்க்கு பேர் என்ன, ஸ்பாட் சைஸ்ன்னு சொல்லுவாங்க. மேபி அந்த ஸ்பிட் சைஸும் ரிலேட் நினைக்கிறேன். தட் இஸ் ஹவ் ஐ திங்க். ஏன்னா நீங்க அந்த கோர் பத்தி தான் படிக்கும்போது பார்த்தேன்னு சொன்னீங்க, அதனாலதான் சொல்றேன். சரியா? ஓகே, ஓரளவு கிளியரா இருக்கும்னு நினைக்கிறேன். இன் கேஸ் I could acquire more information about pit size, I will put it on you. Okay. Okay. Thank you, ma. Yes.